All right, we just introduced the idea of the chi-square test for independence. So now let's just, as usual, go through the steps for hypothesis testing for this test, the chi-square test of independence. And the hypotheses, which we've already looked at, the null is that the two variables are independent, and the alternative is that they are dependent. So independent under the null and dependent under the alternative. Step 2, select alpha and our sample size. Step 3, calculate or test statistic, which we have seen before. In fact, these steps are essentially identical to our earlier chi-square test. Step 4 is to determine your rejection region or use your p-value approach. Again, this is the same as before. The key difference, though, is the degrees of freedom. So here it's r minus 1 times c minus 1. So you take the number of rows, subtract 1, take the number of columns, subtract 1, and that is the number of degrees of freedom. And the p-value approach, as usual, is just the chi-square for r minus 1, c minus 1 degrees of freedom exceeding our chi-squared stat, which comes from step 3. Our conclusion, which is we will reject the null and accept the alternative if our chi-squared stat exceeds our critical value, which is chi-squared r minus 1 c minus 1, and I should probably write alpha here. Or if our p-value is less than or equal to alpha. Otherwise, we'll fail to reject the null hypothesis, and we should always provide an interpretation. So, like I said, these steps are essentially identical to our earlier chi-squared test. Really, it's just the degrees of freedom, which are new. R minus 1 times C minus 1. Before, we just had C minus 1. So let's return to our example. And now this is actually a follow-up example. So we're interested in why customers are not returning to the hotel. So why are they not returning? So let's first note that we have 187 observations. So let's go back to our earlier table in the notes. And if we just take a look at this, if we look at would you choose hotel again? No. The total here was 187. So we're interested in this 187. We're digging a little deeper into this group of people. Okay. So that's why we have 187 observations. So here on the left, we have the observed frequencies. Here on the right, we have the actual. I should not say actual. Here, we would have expected. So we've already done the calculations, and we know we're going to do these in Excel. So I decided to just go ahead and provide those expected frequencies for us. But we would do this exactly the same. So how about just for the sake of completeness, let's just quickly do amenities, Golden Palm. So here I'm just trying to find the expected value. So the expected value here, so we would do 67 times 88 divided by 187. So 67 times 88 over 700. If you do that, you'll get 31.53, which is where this number comes from. So it's exactly the same as before. You just take your row total times your column total divided by your overall total, and that gives you the expected value. Okay. So now let's go ahead and do a hypothesis test. So let's start with our first. So our null is that hotel, and primary reason for not returning are independent, and And our alternative the hotel and primary reason for not returning are dependent. Right, those are our two variables here. We have primary reason for not returning. Those are our rows. And then we have hotel, which are our columns. Those are our two variables here. Okay, 2. So we'll just keep using alpha equals 0.05, and our n here is 187. So 3, which would be our chi-squared stat, which is summing over all cells, f observed minus f expected squared divided by f expected, which again, this is exactly the same as we did before. So we would do 23 minus 31.53 squared divided by 31.53. So I already have these calculations, and we'll do this one in Excel as well. So 27.41 for chi-squared stat. Now let's move on to our critical value approach. So our rejection region will be if chi-squared stat is bigger than chi-squared 6 degrees of freedom 0.05. Where did I get that? Well, remember, degrees of freedom is r minus 1 times c minus 1. So we have 4, 1, 2, 3, 4, 4 rows, and 1, 2, 3 columns. So we have 4 rows, so this would be 4 minus 1, 3 columns, so 3 minus 1, so that is 3 times 2 is 6 degrees of freedom. So that's where 6 degrees of freedom comes from. So this will be chi-squared stat bigger than 12.59. Again, this is something we're just going to get these numbers from Excel. Of course, if you want to use the tables, you can, but Excel's a little easier. So p-value approach. So we know that p-value is equal to the probability, so this will be chi-squared 6 degrees of freedom bigger than our observed test statistics, so chi-squared stat, and that is the probability chi-squared 6 degrees of freedom bigger than 27.41, which is going to be 0.001. It's less than that, but we'll just use that number. Okay, conclusion. So let's first do critical value approach. So our chi-squared stat is equal to 27.41, which is bigger than 12.59, which is chi-squared 6 degrees of freedom, alpha 0.05. And so we can see chi-squared stat is clearly in the rejection region, and therefore we will reject H naught, accept HA. We wanted the p-value approach. Well, p-value is equal to 0.001, which is less than 0.05, which is our alpha. So we will reject H naught and accept HA. Of course, you only have to do one of two of these methods, so use whatever you're most comfortable with. And then finally, our conclusion. There is enough evidence to conclude that the hotel and primary reason for not returning are dependent at the alpha equals 0.05 level of significance. All right, and that's the test for independence. So we say that there is a relationship between these two. So then if we're in charge of this hotel, the next step would be to identify, okay, what seems to be the most important. And there are sophisticated methods for doing that statistically, but you could also just create some plots, look at some proportions, and determine that visually. We're not going to go further with this. We just don't have enough time. But here we can just say there is a relationship between reason for not returning and which hotel they went to. So, like I said, the next step, we just need to be aware that we would then need to identify, okay, where are things going wrong? Is the Golden Palm, say, have poor dining options, and that's why people don't want to return, compared to, say, like the Palm Royale?